Alright folks, welcome to another video on the Grind 75 journey. We're working on number 31 here, longest common prefix. My previous recording cut out, so this is why you find me sort of in the middle of thought here. And I'm actually going to start off by pretty much getting rid of most of this, because after doing some thinking, and the previous recording, I don't know, took about 20 minutes, half an hour. I think I'll throw up the amount of time elapsed there before. But this is what I had so far before that. I then spent a little bit thinking off camera, and I realized maybe actually that maybe we could get away with a sort of kind of a greedy approach, in the sense that here's what I'm thinking. I think I was thinking more about something like this. A flat low, right? So here we have an F, we have an L, and then we have an A. This doesn't work. T doesn't match with anything, but here we have low, L-O-W. It is still a prefix as far as I understand it. Unless a prefix in this case doesn't count because there are words before it. Let me actually flow and a flat low. If this returns an empty string, then we need to reconsider how our model works. Strings must consist of... Oh. Then we need to reconsider how our model works, because we're dealing with prefixes as well. Size is not a reference. Unsolved reference. Does sort by not do what I expect it to do? Sort by... Oh, this is in place, right? So this doesn't quite work because strings won't return anything. So and I do understand that it's a little bit messy to work with, to mutate the input. However, I don't think it's a huge issue. And it's just size without function invocation. Expected, okay. Okay, right. Okay, so it must be without any letters in front of it. So if they start with the wrong letter, then it's GG. I don't know what else to say. So actually, in that case, then this is like completely friggin' overkill. This is just like overkill to the max. Okay, so we can still do the sort. Actually, the sort is actually quite nice. Correct solution. I'll call it an n pointer solution. Check the value of all of the other elements at that index. So cool. So we'll do strs0 dot for each character. And we'll do string builder dot or we'll do a val string builder is equal to string builder. And this is an empty string builder, right? And then we'll say if, so now we want to check through, and actually if size, this is still fine. This is still an edge case. We'll start checking the shortest string, and we'll check all the other characters. So for I in 1 to strs length, if character is not equal to strs I indexed index return string builder dot to string. And if we actually make it through this, then we can do string builder dot append character, right? And we can say at the end return string builder dot to string in case we make it through. So basically what this does is that it'll check for each character within the shortest character, because it's only the shortest character that can possibly be our prefix. And it checks that for all the other characters, that if they have the same letter at that index, then we can continue, and then we can eventually append it on. If it does not, then we immediately say, okay, then we're done. We can just return whatever we have so far in the prefix. So this is sort of like an endpointers-ish solution. And just doing some raw analysis of my actual implementation. So we are checking this. So it's O of n log n for the sort, plus O of s for the shortest string, multiplied by n, which is the number of strings in the list. Technically -1, but like that's amortized or whatever, right? It doesn't really matter that -1 in the grand scheme of things, because we are checking individually. We have to check all of the other strings in our array for each iteration. And at the worst case scenario, all of them make sense up until the shortest string, the length of the shortest string. The length of the shortest string could be equal to the length of all the other strings, in which case that's just, well, the length of all the strings multiplied by the number of strings. And I think this makes sense. There's, oh, size. All right. And let's do some more test cases. Array out of bounds exception here. Strs I. Ooh, which one was the out of bounds? We've got two going. Array index out of bounds, so I'm guessing that's the array index. I thought this was exclusive. Is, oh no, it's inclusive. Whoops. Yeah. I always forget that Kotlin for loop is inclusive. Okay, so that I felt okay. Okay, let's give this a shot. 69.51% speed. Nice. Yeah, so I was overthinking this problem by like a mile. I mean, I have a feeling that maybe eventually, because the way that I was thinking about it, I guess it was like longest common substring, substring. I think longest common substring, but n ways. And that was sort of what I was thinking about. But um, of course, this is LeetCode easy, and I need to stop overthinking these damn problems. But that was a fun exploration into things. But again, the word prefix here is very, very important. And I think this is a decent enough solution, so I think I'm just gonna call it there. This has already lasted way longer than it should, but yeah, I hope you enjoyed something. I hope you uh, learned something about this approach. If you have a better approach, feel free to let me know in the comments. I'm definitely open to hearing suggestions. Maybe not exact code, because when you copy and paste straight up code, then it's not really a great explanation. But I'd love to hear about any additional improvements I can make on top of this to improve the speed of my code, at least in an asymptotic manner. But other than that, I hope you learned something, and I'll see you for the next video.